How do you solve GED math, distance, and cost problems? Well, that's what I'm going to cover in this video. Hi, this is Parker from Test Prep Champions, teaching you how to pass the GED fast. And you can get started by clicking subscribe down below and hitting that notification bell. So let's get right into the video. Let's start off by talking about distance. So the distance is equal to rate times time, and you'll commonly see this written as D equals RT, where D stands for distance, R stands for rate, and T stands for time here. So what are we talking about by distance, and what kind of problems can we solve? So let's say that they leave their house and they walk down the sidewalk, for example, and they go for a 1 mile walk. So that distance would be 1 mile, or the distance could be if somebody throws a frisbee. So one person throws a frisbee to the other person, the distance would be the distance that the frisbee traveled. So we're just talking about the distance that something or somebody travels, and by rate we mean the rate at which that person travels, or the rate at which that object travels. And of course the time is just the time it took for that travel to occur. So let's say, like I said, a person leaves their house and they walk a mile. The distance would be the mile, the time would be the time that it took them for the traveling to occur, and then their rate would be the rate that they're moving. So for example, speed is a common rate. So let's look at rates here, because it's important that we understand what I mean by rate. So what is a rate, or what does a rate do? Well, a rate compares a quantity to 1. All right, so that's all a rate is. So a rate is just comparing a quantity to 1. And so basically what you want to think of here are, let's look at some common examples of rates so you'll see what I mean. So let's stick with speed. So speed could be, for example, if you're driving down the highway, maybe 65 miles per hour. All right, so 65 miles would be the quantity, and quantity is just a fancy word for a number or for an amount. So in this case, the quantity would be the miles, so 65 miles per 1 hour. All right, so that's one example of a rate, 65 miles per hour, and we see here that we have 65 miles per this 1 hour. All right, so that's one example. So another one could be your heart rate. So for example, let's say that someone goes to the doctor and the doctor takes their blood pressure and does some tests and says your heart rate is 70 beats per minute. So what does that really mean? 70 beats per 1 minute is what it means. So that's an example of a rate. That's heart rate. Now let's say, for example, that you have a job, or let's say someone you know has a job and they're making $12 per hour. So what is their rate of pay? So the rate of pay would be $12. So here your quantity is the $12, and then we've got per 1 hour. So again, that's all a rate is. You're just comparing a quantity to 1. So these are a couple examples of rates just to help you understand what we mean by rate. So this is a typical distance problem example, and this is one of the more straightforward cases. So you can pause the video now and try to solve this one on your own. How many miles can you travel on a bike if you ride at an average speed of 9 miles per hour for 2 hours? So pause the video and take a stab at this. Okay, let's go over how to do this. So this is a little bit of a word problem here. So when we do word problems, we want to remember this acronym here, FIOS, okay? And so if you haven't seen my other videos on word problems, I'll put a link down below. But basically, to solve a word problem, you want to use the strategy here. So the F stands for find. So we want to figure out what we have to find. So the question says, how many miles can you travel on a bike if you ride at an average speed of 9 miles per hour for 2 hours? So how many miles can you travel? So that is what we want to find. And how many miles can you travel? Well, that's asking about a distance. So what we want to find here is the distance. So I'm just going to write find, and I'm going to put a D here for distance. So we need to find our distance. All right, and so the F in FIOS stands for find. The I stands for information. So what information are we given, and what information is necessary to solve the question here? So let's look at the other pieces in the question that we're given here. So if you ride at an average speed of 9 miles per hour, so this number 9 miles per hour is going to be important to us. And we also see for 2 hours, so we've got a 9 and we've got a 2 here, all right? And so which one is the rate and which one is the time? Well, the time is always going to be very straightforward. So if you just see 2 hours, okay, or if you see minutes or seconds, whatever it is, okay, that's going to be your time. So 2 hours is going to be our time. So T is equal to 2 hours here, and I'm going to abbreviate hours with HR. And so that leaves the rate to be 9, so we've got 9 miles per hour. All right, so I'm going to abbreviate that as 9 mph for 9 miles per hour here. So whenever you see the word per, okay, per is a clue to you that you're looking at a rate here. So whenever you see the word per, instantly think of rates. So when you see a question like this, 9 miles per hour, that word per is your clue that 9 is your rate here. Okay, so now what are we going to do? Well, we need to find our d, or our distance, and we know the t and we know the r. So let's substitute these into our equation here. So what do I mean by substitute them into our equation? So our equation is d equals rt. And so we want to take this t here and we're going to substitute the value 2 into our equation for t. And then we're going to do the same thing with this r here. So we're going to substitute a 9 into the equation for r. And this is what it's going to look like. So distance is going to equal our rate, which our rate is 9 miles per 1 hour. Per 1 hour. Okay, and so what about the time here? Well, the time is 2. So we've got 9 miles per 1 hour times 2 hours here. Okay, and so what we want to note here is we see the units. We see 2 hours and we see 1 hour. Well, hours divided by hours, these units are going to cancel out. And so now we're just left with 9 miles times 2. All right, so what is 9 times 2? Well, that's 18. And miles doesn't cancel out, so the unit is still miles here. And so our distance is 18 miles. So the distance here is 18 miles. So we already skipped ahead here in our file. So O is for operations. Which kind of operations do you want to use? Division, addition, subtraction, multiplication. And so in this case, since it's a distance formula problem, we just need to go right into the distance formula, and then we did our operations, which were our multiplication here, and we did a division because we canceled out the hours here. All right, and so the S stands for solve and sense. So the S is just solve the question, which we already did when we did 9 times 2, and ask, does your answer make sense? And so since we're finding a distance, we want to get some kind of unit of distance like miles, so that part makes sense here. And so now what we can do if we really want to double check this is we could plug 18 back into the equation here, and we could say we could take this 2 here, and we could then see if r would be still equal to 9. So let me do that here. Let me show you what I mean. So the distance is equal to 18, but we're going to check it here. And so the way that we're going to check it is we're going to take this equation here and we're going to rearrange it to solve for t. All right, so let me clear this work out of the way. Hopefully you saw how I did that already. If not, you can rewind the video here. So let's say that we know that the distance is 18, and we want to check and see if that is the correct distance. So let's just pick one of these numbers. Which one do you want to work with here? 9 or 2? Well, let's just work with the 9 here, and we'll solve for t. But you could just as easily have left the 2 in here for t, and you could leave r as a variable. So when I say the word variable, I'm just talking about something that we don't know. So right now when we've got 18 equals 9 times t, I'm just talking about t as a variable. So t is our variable, which is another word for unknown. So we've got 9 times t. So what we want to do here is get the variable by itself. So how do we do that? Well, we have 9 times t, so we need to do the opposite operation. So the opposite of multiplication is division, so we divide by 9 on this side. 9 divided by 9 is 1. 1 times t is just t. And so whatever you do to one side, you always have to do it to the other as well. So what's 18 divided by 9? Well, 18 divided by 9 is 2, so we see that t equals 2, which is correct because the original 2 that were given in the question, the original time is equal to 2. So what we did here was we just took that extra step here to check and see if our answer made sense, because we solved the question first. We found that the distance was 18 miles, and we wanted to double check it. So we just plugged 18 in for the distance, and we used the rate that was given in the question. We tried to solve for t, and the t was 2, which is the given answer. So that's just a way that you can check your answer. Now, if you're pressed for time on your test, which usually you will be, you don't have to necessarily do this step, but I'm just showing you how to do it using that extra step here, all right? And so let's move on now. The case was simple enough, right? We were just given the rate and the time, and we had to find the distance. We just simply took the rate and the time, multiplied them, and got the distance. But in some cases, you're going to be asked to solve for the rate or asked to solve for the time. So what do I mean by solve for rate or solve for time? So when I say to solve for rate, I just mean get rate by itself on one side of the equation. So right now, this equation is solved for d. We have d equals rt. So the equation is solved for d, and that's just a fancy way of saying that we have d by itself on one side of the equation. And in this case, it's on the left-hand side of our equation here. So let's say that we had to solve for the rate. How would we do that? Well, we see that we've got d equals rt here, right? And so this rt is really r times t here, and I put this little dot here just to emphasize the multiplication here. So if we wanted to solve this for r, that just means that we want to get r by itself on the right-hand side of the equation. So we've got r times t. So how are we going to do that? How do we get r by itself? Well, we've got to get rid of the t, right? So since it's r times t, to get rid of that t, we have to do the opposite of times, all right? The opposite of multiplication is division. So we divide by t. So again, t divided by t cancels out. And it cancels out because anything divided by itself is just 1, right? So you can think of it as t divided by t is 1. R times 1 is just r. We don't even need to write that 1 there. All right, but we're not done because whatever you do to one side in math, you have to do it to the other. So since we divided r by t, we also have to divide d by t, all right? And so to clean this up here, we can say that d divided by t is equal to r. So why does this matter? Well, let's say that you're given a question on your test where you've got to find the rate. You're given a distance and a time and you've got to find the rate. Okay, d equals rt is only going to help you if you can rearrange this equation in order to solve for r. So, there's one thing you can do here. You can say, well, you know what, just in case I get a question on the test where I'm given a distance and a time and I have to find the rate, I can memorize that r equals d over t. But to make it even simpler, you don't need to do that. You just need to know that you'll have d equals rt on your formula sheet, and you just need to know how to rearrange this to solve it for r or to solve it for t as needed. So for example, if we were given, let's say again, we've got distance equals r times t, and let's say we needed to solve the equation for time. Well, we would just do basically what we just did. So if we want to get t by itself on the right-hand side of the equation, we would just say, hey, we have r times t here. Well, the opposite of multiplication is division, so I need to divide an r here, and so r divided by r cancels out, and we're just left with t, and whatever you do to one side, you have to do to the other. So we would see that t is equal to the distance divided by the rate. All right, and so again, if you really want to, what you can do is you can memorize these. You can memorize that r equals d over t, that t equals d over r, but I don't necessarily recommend that. I recommend just knowing that you're going to get this d equals rt on your test, and knowing that if you need to solve for the time, you can rearrange the equation, just as I showed you how to do there to have the t by itself on the right-hand side of the equation. All right, and the same with the r. So let me show you an example where you would have to do that. So here's the example. How long will it take you to drive 300 miles at an average speed of 65 miles per hour? So pause the video and try to figure this out on your own. Okay, let's go over how to do this. So let's say that you're given this question on a test, and the only formula that you have on your formula sheet on your test is d equals rt. Okay, so how is this going to help you if you forget what those other formulas were? So first of all, before you even try to do any math, I recommend following the FIOS approach to how to go through a word problem, right? So again, that's FIOS, F-I-O-S, and again, I have videos on how to do this, so I'll put a link to those down below, and also look for the pinned comment where I'll pin a comment at the top where I link to these videos, because I have 2 videos, at least 2, where I break down how to go through this approach to getting word problems right here. But anyway, the idea here is that before you just jump in and start to solve a word problem, you want to just think about what you have to find here. So the question says, how long will it take you to travel? How long will it take you to drive 300 miles at an average speed of 65 miles per hour? So what are we actually being asked here? Well, we're being asked how long. So how long? What is that? That implies that we're talking about time here. Okay, we're talking about time. So what we want to find in this case is time. So let me write this up at the top here. So we've got f, or in this case, what we're trying to find is the time. So we need to find our t. So now let's look at what we're given. So we did the f. We looked at what we need to find. So I is the information. So what information are we given, and what information do we need to solve the question here? So in other words, what other numbers do we see here? So we see 300 miles at an average speed of 65 miles per hour here. All right. And we also want to pay attention to the units surrounding the numbers here. So 300 miles, what is that? Well, that is a distance. So let's take stock of what we've got here. So d equals 300, and I'm not going to write miles here because we'll run out of room, so let's leave the units out of this calculation. The units are just like miles, or it could be inches or feet. All right, that's what I mean by units here. So in this case, the units are 300 miles. There are the miles, and we're not going to write those to save space. So what about the 65 miles per hour? Well, there's two ways that you would know that this is rate. So number one here, okay, we're talking about average speed. So that right off the bat, remember when we're talking about average speed, that's talking about a rate. But also 65 miles per hour. This word per here, all right, is an indication that this is a rate. So the rate is 65. So rate, or I'm going to abbreviate that with an R. So R equals 65 here. So we now have our t, or we don't have our t, but we've got our d and we've got our r. But how do we find t if we're given this here, d equals rt? Well, what you can do here is just start from this d equals rt, and we're just going to solve this equation for t. In other words, we're going to get the t by itself on one side of the equation here. So how do we do that? Well, again, we see that d equals r times t. We want to get the t by itself here. So we need to get rid of the r here. So we see r times t, so we do the opposite of multiplication, which is division. We divide by r on this side of the equation, and whatever you do to one side, you always have to do the other. So we end up with, and I'm going to just flip this around here, t equals d divided by r. All right, so now this is going to be perfect because what we need to find here is t. So we rearrange our equation so that we've got t on the left-hand side of the equation and it's by itself here. So we rearrange the equation to get what we need to find by itself on one side of our equation here. So we have t equals d times r. Now what we're going to do, since we know that the distance is 300 miles, we're just going to take that distance and we're going to take the number, which is 300, and we're going to substitute that into our equation for d. Now we're going to take r, which is 65, so r equals 65, and we're going to take that 65 and substitute it into our equation here for r. All right, and so now let's put the actual numbers to this here. So let's say I'm just drawing an arrow to show that we're moving our work over here. So we have t equals 300 divided by 65. And if we just throw this in our calculator, what we find out is that we're going to get about 4.6. So the answer is 300 divided by 65. That answer is about 4.6, and the unit here is hours. All right, so the answer here is 4.6 hours, give or take, all right, because it depends how you would round this, but the answer should be about 4.6 hours if you do that in your calculator, all right, and so that's how you would solve for the time in this situation. Okay, so what we just did here is we took that given information and we took stock of it. So I crossed our eye out. So this over here, this find and the D and the R, this is just taking stock of our information. And O is for operations. So what operations do you need to do? Addition, subtraction, multiplication, division. And so in this case, the operation just involved this formula here. All right, so, and then the S is solve, and does your answer make sense? So we solved it doing the calculation in 4.6 hours, and does that seem reasonable? Yeah, that seems reasonable. And so if you really wanted to, you could go take this time, you could substitute it into the equation, and you could just check it to see if it's going to work, and it's going to give you, see if it's going to give you the distance, or you could see if it's going to give you the rate. Okay, but for the sake of time here, pun intended, we're going to skip that. All right, so now this is also something else that's very important to take a look at here. So let's say that, let's put some numbers here and let's give an example here. So let's say that you are going biking here, and so you bike at an average speed of 4 miles per hour. So your rate is 4, and let's say that your time is 2 hours. So let's say that you bike for 2 hours at a rate of, or a speed of 4 miles per hour. So what is your distance here? Well, 4 times 2 is 8, so your distance would be 8 miles here. Okay, and so now let's say that you ride for 2 hours again. So you go out on your bike for 2 hours, but this time you go twice as fast. So this time, instead of going 4 miles per hour, you bike at a speed that's twice as fast. So 4 times 2 is 8. So now we've got 8 times 2, and that is going to give us 16 here. So what happened here? Well, in this case, what happened was you biked for 2 hours at 4 miles per hour, and that was a distance of 8 miles that you traveled. But then when you biked for the same amount of time, for that same 2 hours here, okay, you biked for that same amount of time again, but you doubled your speed, and look what happened. Your distance also doubled here. All right, so this is a very, very important idea, and this is more of an advanced concept for math, but if you understand this, it's gonna really help you with problem solving, and it's gonna help you with understanding math in general. So what I want you to note here is that when the time was held constant, so when we kept the time the same, all right, so in other words, when the time is held constant, but we doubled the rate, the distance also doubled here, okay? And so what this means here, okay, so the way that we would write this is we would say when t is constant. Okay, so when the time is constant, all right, we would say that the distance is directly proportional, and that symbol, let me see if I can draw that symbol a little bit better here. That's a little bit better. The distance is directly proportional to the rate. All right, so that's what this means. So the distance and the rate are directly proportional when t is constant. And so we see that that's what this little symbol here means. All right, and so again, the distance and the rate are directly proportional when t is constant here. So again, if we look at our distance here and we look at the rate, we know that they are directly proportional when the time is held constant. So what does directly proportional mean? So that means that if we double the rate, then the distance is also going to double. And if we triple the rate, then the distance will triple and vice versa. So let's say we quadruple the distance, then the rate is also going to be quadrupled. And on the other hand, if we divide the distance by 2, we would divide the rate by 2 as well, because they are directly proportional when t is constant. Okay, so now on the other hand, let's say that this time, all right, so let's say that you're biking again. And so this time, let's say that you keep your speed the same, right? So let's say that this time you're biking here and you keep the speed the same. So you go at a speed of, let's say, 5 miles per hour and you bike for 2 hours. All right, so what was your distance here? The distance would be 10 in this case. All right, and so now, like I said, we're going to keep the rate the same. So let's say that now you bike at that same speed. So your speed is still 5 miles per hour, but you double the time. So let's say that you stay out there for an extra 2 hours here. So you stay out there for 2 hours longer. So what's 5 times 4? Well, 5 times 4 equals 20. All right, so what does this tell us here? Well, if you ride at that same speed, but if you do it for twice as long, you'll have gone twice as far because the distance has doubled here. All right, and so again, the lesson here in this case is that if the rate is held constant, so the rate is 5 and 5 is not changing. All right, so if the rate is held constant and the time is doubled, the distance is also going to double. And so again, here's another relationship that is important to understand here. So if r is constant, okay, so if r is constant, then distance is directly proportional. Distance is directly proportional to the time. All right, so when the rate is constant, the distance and the time are directly proportional. And again, what does that mean? Well, that means that if the rate is unchanged, so if the rate is the same, if you double the distance, it also doubles the time, and vice versa. If you divide the distance by 3, you also have to divide the time by 3, and if you divide the time by 3, then you'd have to divide the distance by 3. So if r is constant, d and t are directly proportional. Okay, here's another example of this. So let's say that you go biking and you bike 16 miles and your rate was 4. So you traveled at an average speed of 4 miles per hour on the bike and you stayed out there for 4 hours, and so the total distance was 16 miles. I'm not going to put the units in here, okay? So now let's say that the next day or a couple days later, whenever you want to go for a bike ride again, you also bike you bike for 16 miles, but this time, let's say that you don't stay out as long, right? So this time, let's say that instead of staying out for 4 hours, you only stay out for 2 hours. So what happens to your rate? Well, if you're going that same distance, then your rate is going to have to double here. All right, so note here that what happened was we cut the time in half, and we see that the rate then doubled, all right, when the distance was held constant here. So what we can say from this is that the distance, when the distance is held constant, all right, the rate and the time are what's called inversely proportional. So let me write this out here. So if d is constant, all right, so if d is held constant, then the rate is inversely proportional to the time. Okay, and so that's what this means. So this symbol here just means proportional, and since it's 1 over the time, that tells us that the rate is inversely proportional to the time. Okay, the rate is inversely proportional to the time. So that means that when the d is held constant, all right, if we triple the rate, then you have to divide the time by 3, all right? Or for example, let's say if we double the rate, then we have to cut the time in half. All right, so these are the kinds of relationships that you want to be aware of. Now, again, this is kind of a more advanced conceptual way to understand this and to understand math in general, but you guys are really smart and you guys can understand this. So whenever you're given an equation that looks like this, I don't care if it's something on the science portion even. If you're given f equals equals m times a, or if you're given the cost formula, which we'll look at in a second here, which is n times r, or any equation that looks like this, right? So we see this d equals rt. I don't care if it's f equals ma or any other equation, all right? The point here is that you should right away be able to look at something like this. So you should be able to look at f equals m times a, and you should be able to know right off the bat what's going to happen. So if I hold m constant and I double a, what happens to f? All right, so what happens to it? So let's say that you're given something like this, and you don't even have to know what any of this means. You just say, hey, this equation, f equals ma, that looks just like d equals rt, and so if m is held constant, if I know that if a doubles, then f is also going to be doubled, because we can see that the f and the a are directly proportional. They are on opposite sides of that equal sign, and if m is held constant, they are directly proportional. All right, now on the other hand, if f is held constant, you should know right off the bat that if m is doubled, what will happen to a? So if f is held constant and we double m, then we have to cut a. A is going to get cut in half, all right? And so if f is constant, for example, if we triple a, what happens to m? Well, m is going to be divided by 3. All right, so that's distance. Now let's look at cost here. So the good news is that if you understood distance, cost is the same exact thing. The formula is just a little different here, all right? So total cost equals number of units times price per unit. So it's different in that C equals N R, all of these variables here, C, N, and R stand for different things than the distance formula, obviously, but the basic principles are all exactly the same. All right, so the number of units and the price per unit. So one thing that is different, though, that is a little bit strange, is that in the distance formula, they write it as D equals RT here, and where they have rate times the time. But for some reason, for the cost formula on your test, it's in most prep books and on the formula sheet, it's going to be written as C equals N times R, where the rate or the price per unit comes after the n, which is kind of strange, because it would almost make more sense, right, to have it be exactly like the distance formula, where it's C equals R times n, just like distance formula is D equals RT, all right? So then it would be, you know, the rates are in the same place in the formula, but that's just a minor thing. That's just how it's written for whatever reason. So just know that they put the number of units first, and then they put the rate second here on the cost formula in most prep books, and that's how it's going to be written on your test as well on your formula sheet as C equals NR. But the total cost is just C, the number of units is N, and the price per unit is just R. And the word per here should be an indication that we're talking about a rate, and so R is our rate here. All right, so let's look at a basic example of a cost problem. Okay, what is the total cost of 6 basketball game tickets if the tickets cost $6 each? So pause the video and try to solve this now. Okay, let's go over this. So again, when we do word problems, we want to remember FIOS here. And FIOS, the F stands for find, the I stands for information, the O is for operations, and the S is for solve and sense. The S does double duty. So again, let's just look at what we have to find here. So what is the total cost? So right off the bat, what we need to find is the total cost. So let me just put an F here, find, and we want to find our C. All right, and let me just make that an equal sign. All right, and so then we have to look at the information. So what information do we care about? Well, we care primarily about the numbers here. What is the total cost of 6 basketball game tickets? So what is this 6? Well, that is telling us about the number of units. All right, so N is going to be equal to 6 here. And what about this? If the tickets cost $6 each, so what is that? $6 each. Well, usually we're used to seeing the word per, and I told you before that per is a good clue that we're talking about a rate. Well, in this case, $6 each, the word each is going to be your clue here that we're talking about a rate here. So your rate would be 6, all right? And so let me just write this out with the units. So $6 per one ticket, all right? Because remember, rates compare quantity to 1. All right, and so just to keep the units on here, so we've got $6 per one ticket, and this N is for 6 tickets, all right? So how would we find the cost here? Well, we just need to find C, so we just need to use the formula here, and we're just going to take the N, which we know is 6, and we're going to substitute 6 in for N, and we're also going to take another 6 here and substitute that in for R. So if we do that, we would see that cost equals 6 times 6, and 6 times 6 is 36. So the total cost here is going to be $36 here. So that's how much you would spend if you want to go to a basketball game. Say it's like a high school or middle school basketball game where tickets are like only a couple bucks, like $6 or something like that. If you want to get 6 tickets at $6 each, you would just multiply together here and it would be $36 here. All right, so that's how you would use the cost formula. And so like I said earlier in the video, everything that we were doing with distance, all right, remember how with the distance formula we were looking at how you would rearrange it if you needed to find the rate or if you needed to find the time, for example. Well, all of that is going to apply to the cost formula as well here, as well as any other formula really on the test that you get. You can always rearrange a formula for a different variable. So for example, let's say that on your test you know that C equals NR, but the question is telling you, it's giving you a cost and it's giving you the rate, but it's asking you for the number of units. So all you would have to do, starting with that cost formula, is you would just say, hey, well, N times R here. What I want to do here is get the number of units, so I need to divide R from both sides of the equation. So we divide R over here, and then we have C over R equals N. And so then, all right, if you're given that cost and you're given that the rate, you would just do the cost divided by the rate, and then that's going to give you the N. So just like we did with the distance formula, all those principles will apply to cost. It's just that the formula is C equals NR, and everything here, we've got total cost, number of units, price per unit, versus distance equals rate times time, but the same basic principles will apply. So that's everything that you need to know about distance and cost for your test. Now you just have to practice it and try different variations of these problems, and you'll get the hang of it pretty quickly.